the network is a bit poor. So we won't waste much of our precious time, but most importantly, remember that we do record all our lessons. So this lesson is being recorded. So before I go deep, honorable members, I would like to just indicate that please do make sure that by the end of each and every lesson that I conduct, you learn something new. So obviously, you can see the drawing I've done there, which is question number 5. So what I'm going to do is to read through the given statement and most importantly, take you through that diagram. And lastly, we will look at the questions in relation to that diagram. So let's see, what are we having there? So there is the statement which says in the figure below, referring to this figure, ACP. So the moment examiner says ACP, ask yourself this question: where is A? Okay, there it's A. Where is C? There it's C. Where is P? There is P. Are triangles with angle C being 90 degrees? Yes, I do agree with that statement. Remember, at all the times where you see that sign, it means you are having a 90-degree angle. Most importantly, it tells you that this is what we call a right-angled triangle. What does it mean? It means to solve questions related to a right-angled triangle, you can use sine, cos, tan, or theorem of Pythagoras. These are what we call the trig ratios, and this is what we call a theorem of Pythagoras. You only use this if you are dealing with a right-angled triangle having that. Let me continue reading the statement. So it continues to say CP. Where is C? Where? Okay, there it's C and there it's P. Makes sense. They're saying CP is equals to 4 square root of 3. Yes, that I can see. So that means this value is the length from point A to point C. Again, they say AP. Where is A? Oh, there is A. And then there is P. They're saying it's 8 units. And DP, where is D? There is D. And then where is P? There is P. They are saying that one is 4. Okay, now it's added. So most importantly, the last statement says, not necessarily the last, but the second statement says PA. Where is P? Where is A? There's P. There's, oh, okay, that straight horizontal line being PA bisects. Very, very much important, ladies and gentlemen. It bisects DPC. Wait. DPC. It bisects that angle P. Remember, guys, very, very much important that you remember this info. When you have something similar to that, and they say you are having a line which bisects, what it means is that it actually cuts this total angle into 2 equal angles. If the total angle is 40 degrees, that means we're having 20 there, we are having 20 there. Why? Because they're saying this line, it bisects this. I hope that makes sense. So it's written in this way. This is D, this is P, this is C. So they're saying this line AP, it bisects DPC. So this means in triangle DCP, angle P, it is the one which is being bisected by that line. Very, very much important, ladies and gentlemen, on that one. So now let's continue. They are saying let in triangle CAP, angle A, let it be X. And lastly, in triangle DAP. Angle A, let it be Y. As you can see there, honorable members, it means that angle in that top triangle, it's X. The angle in the bottom triangle is Y. So I think now we can start trying to answer the questions. I'm pretty much sure that you guys were reading all that information that I was reading. So to everyone who's attending my lesson for the very first time today, remember, if this is your phone and this is the screen of your phone and you're having list of attendees, click here so that you can maximize the screen. You will be able to see everything on your screen. So don't let it look like this where you see a list of attendees, because now this is my whiteboard. So that means this part you won't be able to see. That's why I'm saying click there. I hope that makes sense to everyone. So good people, I'm about to now start answering the questions, but most importantly, let me give you a very quick prayer there, ladies. So when we have a right angled triangle, and just a triangle, which could be a scalene or isosceles. Remember, under a right angle triangle, how do we notice right angle triangle? That's if it is that shape of a triangle. Most importantly, it has to have that. Doesn't matter what shape it looks like. As long as it has that, it's a right angle triangle. So that means we can use sine, which we know that it's opposite over hypotenuse. You can also use sine, cos, which we know it's x over r. We can also use tan, which we know that it is y over x. And also, what is it? Theorem of Pythagoras. Libandla la kaNkulunkulu, Leslie the Leslies. You do know very well that we only use this if we are dealing with a right angle. Okay, now, what if it's not a right angled triangle? Just like there, the top triangle is a right angled triangle, the top triangle. The bottom triangle is just a triangle, which could be that or that. So that means by the end of this lesson, you need to Google what is the difference between a scalene and an isosceles. The difference are very much clear. But with this chapter, even if you don't know what is what or which is which, you will still survive. So let's say we just have a triangle. It doesn't matter in whichever shape. So when we are dealing with just a triangle, you use the sine rule, the cosine rule. A bonus question is that one of the area rule. So that's all that you need to be aware of regarding these two types of triangles. I'm just going to remove all of this and very quickly take you a revision, a very quick one. I've actually done this with grade 12s and also on extra weekend lessons. So for those of you who are not attending my extra weekend classes, I'll just do a very quick revision on that. I'm pretty much sure that you also did this in class. I'll call them Akos. This is what happens, honorable member. If you are having just a triangle, remember, we've got the sine rule and also the cosine rule. So now the formula for the sine rule, maybe let's say we're having A, B, and C. The sine rule says you can apply it if you are having an angle and its opposite side. So that's why you can say a sine of that angle B over the opposite side, it's small letter of that angle. This can be equated to, you must also have an angle. Doesn't matter whether it's angle A, but the side has to be that opposite side, which means you are going to say sine of angle A over small letter A. This can also be the same as if you have angle C, you must divide by the opposite sign, meaning it's going to be sine of angle C over small letter c. That's when you apply the sine rule. So that means you need to have an angle, opposite sine, and angle, opposite side, I meant to say. Very quickly, let's look at the cosine rule. This one is also straightforward, but in this case, that's if in a triangle of any shape, maybe let's say A, B, C, D, E, F. In this case, they're saying you must be having this side and this side and an included angle or an angle in between. Otherwise, in a triangle looking like that, you must be having a side and an angle in between. That's if you want to calculate this side which is opposite to that angle in between. That's if you want to calculate this side. So the formula says it is therefore going to be this side. Let's say what side is this? Is D, then this is small d, this is E, this is small f. So that means this side being d squared is equals to this side being f squared plus this side being E squared minus two of those same sides, EF multiplied by, remember, it is the cosine rule. That is why you are going to have cos of that included angle. So the same applies here. That means this is going to be your answer. And you're going to say it's equals to this side squared plus that side squared minus two of those same sides, because it's the cosine rule, then cos of that included angle. So that's all that you needed to know regarding the sine and the cosine rule. Lastly, let's talk about the area rule. So the area rule is actually a friend of the sine rule, because is it a friend of the, no, not the sine rule, but the cosine rule. Yes, you will understand what I mean by that. Remember, if you are having a triangle, let's say something similar to that. This is a triangle. Maybe let's say A, B, and C, and they want you to calculate the area. So the area, we know the area of a triangle is half, let's say, length times breadth. Most importantly, there is always sine of an angle there. This is the general formula of calculating a triangle. Sometimes you might be having something similar to that. Let's say this is 2 and this is 4. And they say calculate the area for that. The area, you're going to say it's equals to half times 2 times 4. You won't bother to say sine of an angle. Why not? Because this is a right-angled triangle. But notice something. Maybe let me rewrite all of that so that it makes perfect sense. So the area is equals to half length times breadth. What is the length? One can say the length is 4. Maybe let's say 4, breadth, let's say 2. So what I'm saying is you won't bother to say sine of an angle. You will understand why I'm saying you won't bother by doing that. But notice something very much important. Can you see? You are saying this side being 4, and you are multiplying it with this side being 2. This sine of an angle, the angle there is 90 degrees. So that means you have an included angle being 90 degrees, of which sine 90, when you punch it on a calculator, it gives you 1. That is why you don't write that sine 90, because it gives you 1 multiplied by 1, it doesn't change anything. Meaning, if you want to understand where that half comes from, it is because just this part, length times breadth, it is actually the area of a rectangle. So this rectangle of length times breadth, it's been cut into 2 equal halves. That's where that half is coming from. And then the sine of an angle, it refers to that angle being 90 degrees, which ends up giving you 1. That means this times that it's 8, half of 8 is 4. So that means the area is 4 units squared. That's how you understand where a formula comes from. In that way, it makes it very much easy for you to apply the formula. Most importantly, that means in a situation where you just have a triangle, you are therefore going to say the side. If you're going to use this side also, if it's given, then that means you're going to use an included angle. Or if it is that side and this side, that means you need an included angle, which you will substitute there. Of which, in this case, it might not be 90 degrees, meaning you won't expect 1 there, but a certain value, which will then result in you getting an area of that type of a triangle, which could be a scalene or an isosceles. So now, libandla la kaNkulunkulu, that's what I wanted you guys to be aware of. So now I'm just going to ask if there's any questions before we start answering exam type of questions. Good people, anyone who's got a question based on what I've explained, or is it clear to everyone? I see Nikelwa is on the line. Nikelwa, I think you are attending my lesson for the very first time, honorable member. Are you sure I'm not losing you there? Pindi the mapindis. I see it is on the line. Itu, are you sure you are not falling behind on that one, honorable member? I know Leslie, she understands what I've explained. I've explained it multiple times. That was just a revision. So just in case if you missed a full lesson where I explained all of that, if you scroll up in this same group, you will get a link where I said watch before attending today's lesson. So that's when I explained exactly what I've explained, but at a slower pace. So let's see. The first question says, show by calculations that x is equals to 60. This question is allocated 2 marks. So let's see. What are we? Oh, okay. This is what we are showing, that it is equals to 60. I'm telling you guys, this is all that you need to ask yourself. What type of a triangle am I dealing with? Is it a right angle triangle, or is it just a triangle? If it is a right angled triangle, that means you can use sine, cos, tan, or theorem of Pyth. Let's do it this way. If it is just triangle, then that means you can use the cosine rule, the sine rule, the area rule. I think it's going to make it easier that way. Here comes a question. X, is it in a triangle, which is a right angle triangle, or just a triangle? It's in a right angle triangle because of that. So that means you might need to consider using the trig ratios. Here comes a question. Which trig ratio will be relevant in us calculating that? It seems like a sine, it's going to be the relevant one because we've got the side which is opposite to the angle. And again, we have that hypotenuse. So that means sine of angle x is equals to opposite, which is 4 the root of 3 divided by, I think this is now 8. So let's see. Obviously, x is going to be equals to second function of. Obviously, that cancels, it goes 2 times. It's more like you're having that over that. So when you punch that on a calculator, what are you guys getting there? Otherwise, someone can still draw that. I think 60 is down there. Is it square root of 3, 1 and 2? I think I forgot that where 30 is there. opposite over hypotenuse. Yes, can you see? That is the one which gives us 60. I'm suspecting. Guys, when you say second function of that, does it not give you 60? Maakos, what are you getting there, honorable member? Luyanda? Silence. Let me calculate on my side.
It gives us 60.
Yes. Yes, let me just quickly confirm. Yes, 100%. It does give us 60. So that's how very quickly you show that it is actually equals to 60. So since we have calculated it, let's write it there to say that it's equals to 60. So now let's try move on to the next question. I'm hoping to work out these questions as soon as possible so that I don't lose network since it's load shedding on my side. It's unfortunate it's raining today, so that is why. It's not like my schedule is such that during this time I'm supposed to be having load shedding. So let's see. Calculate the length of AD. That's what examiner wants you to calculate, the length of AD. The question is, where is AD? There is AD. In which triangle? In the bottom triangle. Is it a right angle triangle? No. That means we cannot apply those, but you might look on the right side, hoping to apply the cosine or the sine rule. So now, what are we given? We realize we are actually dealing with that triangle where we know we are having 8 there. Some lightnings on my side. We are having 4 there. Anyone who would like to suggest how can we possibly work out this question where we calculate the length of AD? Anyone would like to suggest how to work it out? Remember, in case if you got my question and you've got no idea, please do feel free to say no idea. Pindi, did you get the question, honorable member? If you say no idea, then I won't wait and I'm going to explain. But if you keep quiet, I'm going to think the message is still on the way.
No idea, sir.
No idea. Let's see. Kitu is on the line. Kitu, do you not want to guess, honorable member?
No,
Or is this
sir.
only Kibupilo?
Please, sir, please explain.
Okay. I'm just going to make an assumption that so let's see. Very, very much important that you remember the information given. I'm not sure if you guys remember examiner saying something bisecting something. Do you not remember that, honorable members? From what I remember, they said this line AD, it bisect this whole angle, obviously into 2 equal halves. So that means if I can know what this angle is, then I'm going to be able to know what that angle is. Therefore, I'll be having that, and I can either use the sine or the cosine rule. I'm not sure if it makes sense, honorable members. What I've just explained, does it make sense before I go deeper?
Makes sense, sir.
100%. Now, what is that angle? This is where you now need to remember that the sum of interior angles of a triangle equals 180 degrees. So that means in a triangle having three angles, let's say angle number 1, you must plus it with angle number 2, you must plus it with angle number 3, and they must all give you 180 degrees. So you have 90, you have 60. I'm not sure whether you call it 60 or you call it 60. But whatever it is, honorable members, we know that we are having 180, which is equals to 60 degrees, 90 degrees, plus what is it, angle at P. Or let's maybe write it this way and say in triangle APC, angle P is what we're talking about. So this plus that, I think this is 150. You take it to the other side. Is it not 30? I think it's 30. So that means in this triangle APC, angle P, it is the one which is 30 degrees. So that means so that angle there, it's equals to 30 degrees. What does it mean? They just said this line, it bisects, meaning it cuts into two equal halves. You can also see examiner gave you a hint. He did this, that, to show that this is equals to that. But if you look at that, you realize it's one line is two lines, meaning this angle and that one are not equal. So those are the hints, signals. Signal, o examiner usinikeza signal bantu bakithi